So, very good evening to the students who have joined. Can you kindly let me know in the chat box if my voice is audible and the video is visible to you? Okay, great. So, we will wait for a few minutes and then after more people join, then we will start our session, okay? So, now is the screen visible? Just let me know in the chat box if you can see the PPT. Okay, sure, thank you. So today it is the week 11 live session and we will discuss our last week, means week 8 course content today. Okay, so very good evening to the students who have joined. My name is Moshumi Dev and I am the PMRF fellow from the Department of Chemistry and Chemical Biology, IIT ISM Dhanbad. So it is the NPTEL course of Medicinal Chemistry for which the week 11 live session is today, and in this live session we will discuss the course content which are included in the week 12 materials. Okay. So, regarding the week 12 material, we have around 15 to 20 questions, 15 to 20 MCQs, and we will discuss those in today's class. After I show you some question, I will request all the students to answer the question in the chat box. It does not matter if your answer is correct or wrong, but it is very necessary for you to answer the question, or at least you should try to answer the question in the chat box. And in between the class, if there is any issue regarding the internet problem from my side also, so I would like to request you to wait for some time. I will quickly resolve the issue and I will resume the class. Okay, do not leave the class. And today's class lecture video and this presentation, it will be shared to you by the NPTEL website after the end of the session. So let us wait for 2 more minutes and then we will start today's session. And if you have any doubt regarding any question, any part or any point of today's session, please do write me in the chat box. In between or at the end of the session, I will surely answer those doubts. Okay. So I think we should start our class. If more students will, when more students will join, we will just add them up. Okay. So let us start today's. So I think my voice is audible and the PPT is visible to you, right? If you have any problem, please write in the chat box. And now we will start today's session. So the first question of today's session is, which of the following is not a QSAR parameter? QSAR stand for Quantitative Structure Activity Relationship, and your options are number A, hydrophobicity, number B, hydrophilicity, number C, steric, and number D, electronic. So you have to identify among these four which of the following is not a QSAR parameter. Try to answer this question in the chat box. Eventually I will discuss what is a QSAR and which one of the following is not a QSAR parameter. I will discuss in detail, but at first I want all of you to try to answer this question in the chat box. Which of the following is not a QSAR parameter? So is there any answer? Okay, so we have one answer which says hydrophilicity. Okay, so let us check. So the correct answer of this question is very good, number B, hydrophilicity. Now what is a QSAR and what are the QSAR parameters? So a quantitative structure activity relationship or QSAR is a mathematical relationship which correlates measurable or calculable molecular properties to some specific biological activity in terms of an equation. QSAR attempts to find consistent relationship between biological activity and molecular properties so that these rules can be used to evaluate the activity of new compounds. Understanding QSAR regarding electronic effects, steric effect and lipophilicity. So what are the physiological parameters which are related in the QSAR studies? So these parameters are number 1, hydrophobicity, and this hydrophobicity is measured in terms of partition coefficient, pi substituent constant. There are steric parameters which are the Taft equation, Taft constant, World steric parameter, and electronic parameter, it compares of Hammett constant and dipole moment. So these were some parameters. So these were the parameters and which are important in the QSAR or quantitative structure activity relationship. So, what is a normal structure activity relationship or normal SAR? So, in that we have a series of compound where we just vary a few structural parameters in that in the series. So, we have a parent compound and where we design few derivative of the parent compound in which in the derivative there are some structurally changes from the parent compound, and then we compare the activities of those derivative and we relate that which structural feature have induced which activity. Similarly, in the quantitative structure activity relationship or QSAR, we use mathematical relationships, okay, and these mathematical relationships they correlate the measurable or calculable molecular properties to some specific biological activity, and these parameters which are used in KSR or QSAR are hydrophobicity, steric parameter, electronic parameters, okay, and the equations are like partition coefficient, pi substituent constant, Tuft constant, Burloop steric parameter, Hammett constant, dipole moment, etc. Okay. So, this is all about the QSAR, and we will move toward the next problem. Again I am saying, if you have any doubt regarding any question, any point, so just let me know in the chat box, and at the end of session or in between I will just discuss those points, okay, and after every question please try to answer that particular question. So, we will now move toward the next problem. So, problem number 2, it says that which of the following mechanisms is followed for the resistance of sulfa based antibiotics. Your options are number A, target mimicry, number B, efflux pump, number C, drug inactivation, and number D, target overproduction. So, there are very much antibiotics or various other drugs also which are very prone to resistance, and this resistance which is a very important in a drug discovery, like to tackle the drug resistant of the pre-existing drugs. Okay. So, again I will repeat the problem number 2. So, problem number 2, it says that which of the following mechanisms is followed for the resistance of sulfa based antibiotics, and your options are number A, target mimicry, number B, efflux pump, number C, drug inactivation, and number D, target overproduction. So, try to answer this question in the chat box. Which of the following you think is the correct mechanism which is followed for the resistance of sulfa based antibiotic? Again I am saying, it does not matter if your answer is correct or wrong, but if you know or if you want to answer it, you can try. Which of the following mechanism is followed for the resistance of sulfa based antibiotics? The options are target mimicry, efflux pump, drug inactivation, target overproduction. So, is there any answer? Efflux pump, number A. Okay, so I think we have two different answers, right? Okay, so we have two different answers. So, let us check out which is the correct answer. So, the correct answer is actually number D, target overproduction. Okay, now let us discuss. So, overproduction of a substrate or ligand for the target protein. Overproduction of the substrate for a target enzyme would competitively block the ability of the drug to bind at the active site. For example, overproduction of para-aminobenzoic acid as a mechanism of resistance of antibacterial sulfa drugs. So, what are the sulfa drugs? Sulfa drugs were discovered when a red dye called prontosil has shown in vivo antibacterial activity while it was in vitro inactive. This supports the idea that prontosil, to exert its action, it has to be activated by host metabolic pathway to give the active form. Okay, so, this is the red dye which is prontosil, And this prontosil dye, what happened, like when it was in vitro, means when it was in some glass tube or any I mean test tube kind of vessel, so it was inactive. Okay. But when it was studied for in vivo, means it was studied in the bacterial cell culture, so it was found to show the antibacterial activity. Now this supports the idea that when it was in the body, or when it was in the cell, due to some cellular metabolic pathway, the inactive drug became active and it showed its antibacterial activity. Now if you can see here, this is a azo dye kind of material, right. So when it is in the body, it will just divide itself in two parts, and this is the sulfonamide, which is a active antibacterial drug. Okay. And this was the start for the sulfa drugs, and which is a very important or old class of antibiotics. Now sulfonamides mimic para aminobenzoic acid or PABA, which is the normal substrate for dihydropteroate synthesis. This means that sulfonamide will bind to the same manner as para-aminobenzoic acid. So this is the para-aminic benzoic acid, and this is the active site. So as you can see, this ring, it is binded to the active site in this manner. The carboxylate take parts in the ionic interaction, the benzene ring take parts in the van der Waals interaction, and NH2 interacts with the hydrogen bonding interaction. Now this is the para-aminobenzoic acid, this is in the active site interaction. Now the sulfonamide or sulfur drugs, they mimic the structure of this para-aminobenzoic acid, means it takes part in the same interaction as of this para-aminobenzoic acid with the ionic van der Waals or hydrogen bonding interaction, and by this way the sulfonamide drug, they bind to the active site for this PABA and they inhibit the bacterial growth and act as an antibiotic. Now what will happen if the target overproduction happen, means that if in the body the target enzyme, if the para-aminobenzoic acid, it is formed with a very high yield, means if overproduction of this para-aminobenzoic acid happens, so what will happen, so all the receptors, all the active site will be blocked by this overproduction or overproducted this para-aminobenzoic acid, and the sulfur drug will not able to bind the active site of the drug, active site of the enzymes. So that's how it will not able to deactivate, or it will not be able to inhibit the particular enzyme, and that's how the sulfur drug resistance happen in the bacteria. Okay. So this was the target overproduction, and there are many other examples. This is only one example. So I think this is clear to all. So if you have any doubt, I am always telling you, like if you have any doubt, anything during the class, you should tell me. Okay, after I finish some question, and I will try to answer those doubts. So now I will move toward the next problem. So problem number 3, it says that the role of the efflux pumps in drug resistance is due to number A, metabolizing the drug before reaching active site, number B, inactivation of the drug, number C, decreasing the drug concentration inside cell, and number D, none of the above. So efflux pumps are also very important for the drug resistance, for the antibacterial drugs, and you have to identify the correct role of this efflux pumps in the drug resistance. The options are number A, metabolizing the drug before reaching active site. Okay, somebody wants to join. So again I am repeating the problem number 3. So the role of the efflux pump in the drug resistance is due to number A, metabolizing the drug before reaching the active site, number B, inactivation of the drug, number C, decreasing the drug concentration inside cell, and number D, none of the above. So you have to identify the role of the efflux pump in the drug resistance. So I want all of you to try to answer the question. So is there any answer? So number C. So we have Only one answer. Others also try. Which of the following you think is the correct reason or the correct role for the efflux pump in the drug resistance? Okay, so are there any answers extra? Okay, let us check what is the correct answer. So, the correct answer is number C, decreasing the drug concentration inside the cell. So, altered drug distribution to the site of the action. Efflux pumps are the transmembrane protein that are often highly expressed in the microorganisms and the tumor cells that act as the transporters by binding to the drugs and carrying them out of the cell before they can exert their therapeutic effect. Some transporters known as the multidrug resistance pump are quite broad in their specificity and can efflux a variety of natural and synthetic drugs. Both specific and broad specificity efflux transporter systems have been identified that contribute to bacterial resistance to a broad range of antibiotic drugs. Okay. So, efflux pumps in clinical relevance for both bacteria and eukaryotes, efflux pump can confer to multidrug resistance and they can add themselves to other resistance mechanism. They have been seen new target for the drug design. Okay. So, efflux pump inhibitors or blocking the pumps will restore the drug's activity. So, this is the your cell and this is the intracellular transmembrane. So, in this yellow these are the efflux pumps. So, these efflux pumps are the your transmembrane proteins. So, when there is a drug inside the cell, what will these pumps do? They will pump out this drug out of the cell before the drug can exert their antibacterial or any other medicinal benefits. Okay. So, this inhibitor of this efflux pumps are also very important target, important new class of drugs for the antibacterial resistant. So, antibiotic resistant bacteria. So, as you can see, this is the bacteria, okay, and this is the efflux pumps, and when there is a antibiotic is given in the cell, this efflux pumps they eject the antibiotic out, and sometimes these antibiotics are failed to penetrate the membrane due to this pumps also, and that is how the antibacterial resistance happen, and this is a very important target as I have always said for designing new antibacterial drugs which are not actually this efflux pump inhibitors can be given as a combination therapy for the antibacterial resistance. Okay. So, is there any doubt or anything? So, yeah, number C, it was the correct answer. So, now I will move toward the next problem. So, problem number 4, it says that which term is used to describe the inhibition of two different enzymes in the same biosynthetic pathway, and the options are number A, parallel inhibition, number B, sequential blocking, number C, empty therapy, number D, enzyme inhibition. So, if in a particular or same biosynthetic pathway there are two different enzymes, okay, and if there is a inhibition of two different enzymes in same pathway, there is a particular term which is used for this in medicinal chemistry. You have to identify the correct term, and your options are number A, parallel inhibition, number B, sequential blocking, number C, empty therapy, number D, enzyme inhibition. Write in the chat box which of the following you think is the correct answer. It does not matter if your answer is right or wrong, but try to answer the question. So, I think we have two answers till now, number D and number A. Others also try. Which of the following you think is the correct answer? Okay, I will show you the answer, then we will discuss this. Okay. So, the correct answer is number B, sequential blocking. Now, what is a sequential blocking and why it is important? So, inhibition of two or more consecutive steps in a metabolic pathway is known as the sequential blocking. The reason this is effective is because it is difficult, particularly with a reversible inhibitor, to inhibit the enzyme 100%. If less than 100% of the enzyme activity is blocked, the metabolic pathway has not been shut down. So, as you can see, this is a metabolic pathway, let us say. So, there is a number A to B, B to C, C to D and D to E. So, in this there is 4 intermediate states and let us say 4 enzymes are catalyzing each intermediate states. Now, if we inhibit only one of this state, okay, and that is how what will happen, this metabolic pathway will not be will not shut down and to 100%. Okay. So, there will be still the metabolic pathway will go on if we inhibit only one particular enzyme in this pathway. But with the combined use of inhibitors of the 2 consecutive enzymes in the pathway, it is possible to block the pathway virtually completely. So, if you inhibit 2 consecutive metabolic step, so what will happen? The complete metabolic pathway may be stopped. Okay. And let us discuss, let us say A goes to B, goes to C, goes to D, goes to E. So, this is the metabolic pathway that we want to inhibit. Now, let us say we develop an inhibitor of this step. Okay. So, here because D does not get converted to C by the inhibition, you do not get the formation of E, right. But if less than 100% of this course, because we are blocking at the reversible inhibition, it is possible that you would never get the 100% inhibition. So, if there is a less than 100% inhibition of the enzyme activity is blocked, then the metabolic pathway has really not truly been shut down. There is always going some amount of E to be produced. But when you use inhibitor for the 2 consecutive enzyme in the pathway, so there so here we would do is that this A going to B, going to C, going to D, going to E. What should we do? We would not block, would not just block this, perhaps that we are also block this. Okay. So, here we will develop 2 different inhibitors. So, there is a work in synergy. Okay. So, I will again repeat. So, let us say, so if there is this pathway and you are shutting down it here. Okay. So, as this is a reversible inhibition, there is never 100% of the inhibition happening. So, if let us say there is a there is some inhibition and I think let us say there is 70% inhibition. So, 30% of the B is converted to C, means the metabolic pathway is going on, but if you are inhibiting this in 2 way, means you are just inhibiting here. So, 30% of C is produced and again we are just inhibiting it here. So, there is a less chance of the more for more E to be produced, and this is called the sequential blocking. Okay. So, basically inhibition of 2 different enzymes in same biosynthetic pathway, it is called the sequential blocking. So, I think it is clear what is the sequential blocking and why it is important, and most importantly how it works. Now, I will move toward the next problem. So, problem number 5, it says that contour maps are present in number A 1D QSAR, number B 2D QSAR, number C 3D QSAR and number D all of the above. So, you have to identify where contour maps are present. 1D QSAR, 2D QSAR, 3D QSAR or all of the 3. So, is there any answer for this? D it would be. So, I think we have two answers, B and D. So, I want others also to try to answer the questions. Okay. Okay, so the correct answer is number C, 3D QSAR. So, what is a 3D QSAR? A set of active and inactive compounds are required from a congeneric series of the compounds. The compounds are divided into training set and testing set, and the training set compounds are used to build a 3D model. The test set compound are used to evaluate and refine the model. The 3D QSAR model consists of contour maps that indicating the favorable or unfavorable regions. So, this is an example for a 3D QSAR model, and so these are the contour map, or these contour maps actually indicate the favorable and unfavorable regions. So, green it is stand for the sterically favored, okay, and yellow it stand for the sterically not favored, and blue it stand for the electron rich, and red it stand for the electron deficient. So, this is okay. So, what happens in 3D QSAR basically? So, you have a, so we have to take a very long range of the compounds. Okay. So, let us say we have to take some 1000 compounds, and we have to divide the compound in the training set and testing set. So, let us say you are dividing 1000 compound into 8 is to 4:1 ratio, means 800 compounds in the training set and other 200 compound in the testing set. Now, this training set compounds it will be used to build a model, and when the model is 3D model is built, it will be applied to those 200 model for the testing sets, and to check if the model is accurate enough, and what are the things which are need to check and which are need to incorporate in the model to make the model more accurate. And this models actually consist of this contour maps, which indicate very regions for around a compound, which are sterically favored, which are sterically hindered, and which state are electron rich or which state are electron deficient. So, these are the regions are called the contour maps. Okay. So, this was the problem number 5. Now, I will go to the problem number 6. So, problem number 6, it says that which of the following physicochemical properties is least commonly considered for the QSAR studies, and your options are number A, hydrophobicity, number B, electronic influence of the substituents, number C, dipole moment, and number D, size of the substituents. So, you have to identify which of the following physicochemical properties is least commonly considered in the QSAR studies. Is it hydrophobicity? Is it electronic influence of the substituents? Is it dipole moment, or is it size of the substituents? Write in the chat box which of the following you think is the correct answer. So, is there any answers for this question? Okay, number D, number C. So, we have 2 number C, 1 number D. Okay, let us check. So, the correct answer is yes, number C, it is dipole moment. So, dipole moment is the least commonly considered in the QSAR studies. Okay. So, rationally for the QSAR studies, a quantitative structure activity relationship for QSAR correlates measurable or calculable physical or molecular properties to some specific biological activity in terms of an equation. Once a valid QSAR has been determined, it should be possible to predict the biological activity of the related drug candidates before they are put through the expensive and time consuming biological testing. In some cases, only computed values need to be known to make an assessment. So, in the last question I discussed about some training sets and the testing sets, right. So, let us say there is a compound or there are few drugs for a particular disease. Okay. So, let us say there are regarding 100 drugs for a particular disease. Let us say there are 100 anti-cancer drug for a and we have to build a QSAR model regarding those drugs, okay, and to evaluate some new drug candidate. So, what we will do? We will not take the new drug candidate and we will start doing the expensive and time consuming the biological testing on the humans or animals. Okay. So, what we will do? We will first test them in silico, means we will first test those drugs in the computational model, and the computational model it will be built using this QSAR studies or quantitative structure relative to relationship studies, and we will use 80 drugs to build a model, and we will test that model on this remaining 20 drugs to see how much the model is accurate, or what we need to do to increase the accuracy of the particular model. Now, when there are new drug candidate, first we will test this drug candidate using the computational model to see how much efficient the drug is computationally. And if there are, let us say, 10 drugs which are among 50 new drug candidate, there are 10 drugs which are performing very good in the computational modeling, then we will do the biological testing of those drugs which are showing very efficient result using the QSAR models, okay. Because that is how the process will be faster and it will be less expensive and time consuming. Now, QSAR, so calculated from the, so there are various aspects for this QSAR. So, there is geometrical aspect calculated from the 3D coordinate of the atoms, capture the 3D information regarding the molecular size, shape, atoms distribution, that is Gateway, Morse or WIM, these are the softwares which are used. And there is thermodynamic descriptors are used to relate chemical structure to observe chemical behavior. For example, HF or head of the formation, mol ref, molecular refractivity, A log P, etc. Now, electronic, so these are used to describe electronic aspect of the molecular atom bonds and molecular fragment, the dipole moment, homo-LUMO energy, and constructual, these are simple commonly used descriptors reflecting the chemical information of the molecule without any information of the atom connectivity, that is atom and bond counts or molecular weight. Topological, based on the molecular graph, represents the connectivity of the atoms and molecule, used to modeling used for modeling biological, physicochemical and pharmacokinetic properties, that is Wiener's, Zagreb and indices. Okay. So, this is about the QSAR. Now, we will move toward the next problem. So, the problem number 7, it says that which of the following resistance mechanism describes the function of beta lactamase, and your options are number A, flux pump, number B, target mimicry, number C, drug inactivation, and number D, target overproduction. So, beta lactamase, as we all know, is a very important drug, and the resistant mechanism that describes the function for this beta lactamase enzyme, is it a flux pump, target mimicry, drug inactivation or target overproduction. So, is there any answer? Drug inactivation, number D. So, I think we have two answers, right? Let us check. So, the correct answer is number C, drug inactivation. So, there is a type, one second. Okay. So, there is a type of resistance called drug inactivation. Some bacteria can use different methods to render an antibiotic useless, especially by destroying the antibiotic structure. Okay. So, this is the structure of the penicillin or any beta lactamase inhibitor, like any beta lactam containing antibiotic. So, what will this beta lactamase do? This will just hydrolyze this beta lactam ring, and that is how it will inactivate the particular drug. Okay. And as we all know how this beta lactamase inhibitor works. So, this is the pathway how this beta lactamase enzyme. So, beta lactamase is the particular enzyme, and this enzyme, so this is the beta lactam ring of the antibiotic which contain the beta lactam antibiotics. Okay. So, what will happen? So, there is a, see, as you can see, there is a glutamate here and there is a lysine here, and this glutamate and lysine, they are acting as a base, and there is a serine here. Okay. And this serine containing, this is hydroxyl group of a serine, and there is a water molecule. So, what will happen? This base lysine 73, it will take up the proton from this serine hydroxyl group, and this will convert it to O minus, and this O minus will act in this ketonic group, and this ring will be broken. Okay. Now, the glutamate here, it will just take up the proton from the water, and again this water, it will it will convert it to the hydroxyl, and this will attack to this carbonyl carbon, and this and then this bond will broken, and the enzyme, it will convert it to its original formation. Okay. That is how this first step is the acylation. Okay. So, the first step is the acylation step, and the second step is the deacylation step. Okay. And as you can see, this is the structure for this active site structure for this metallo B lactamase. So, there is two type of beta lactamase enzymes are there. So, one of this is the serine beta lactamase, and the serine beta lactamase has the serine which act as a nucleophile here. Okay. And this metallo beta lactamase, it has a metal bound hydroxyl group which acts as the nucleophile and attacks the carbonyl carbon for the beta lactam ring. So, this was the mechanism of the drug resistance which is exerted by this beta lactamase enzyme. Okay. So, this was the problem number 7. So, now problem number 8. So, what does the Hammett substituent constant measure? And your options are number A, steric effect of the substituent, number B, electronic effect of the substituent, number C, hydrophobic effect of the substituent, number D, the effect of pH of the substituent. Now, you have to identify which is the correct answer here, and what does the Hammett substituent constant actually measure? Is it steric effect of substituent, electronic effect of substituent, hydrophobic effect of substituent, and effect of pH of the substituent? Write in the chat box which of the following you think is the correct. It does not matter your answer is right or wrong, but try to answer it. Okay, just excuse me for a minute. Okay, I have to do something. So just try to answer this question. Okay, sorry for the disturbance. Okay. So there is a answer number D and electronic effect. So there is only one answer, right? Okay, let me check which is the correct answer. So the correct answer is number B, electronic effect of the substituent. Now let us discuss what is the Hammett constant and what does it measure. Okay, so there was an answer, right? So what was the answer? Electronic effect. Okay. So yeah, correct answer is electronic effect of the substituent. So now Hammett equation. So the substituent constant. Okay, so this sigma it's called the substituent constant. So comparison of the effects of the same substituent in the meta and para positions. So in case of NH2 group, the absolute value of the sigma para is much larger than the sigma meta. Electron donating ability of the amine group is largely due to the resonance effects. The para position can directly distribute electrons into the carboxyl group of the benzoic acid. Carboxylic group is more difficult to become negatively charged carboxylate ion, low acidity constant. So Hammett constant basically it compares the electronic effect like the electron donating or electron withdrawing group in the meta and para positions. Okay. So depend on the electron withdrawing and electron donating effect, the value of this constant it can be positive or it can be negative. Okay, so this as you can see, as I have said that this contribution for this amine group is much larger because of this resonance effect, and other applications like for example this is the acrylic acid, excellent correlation between the sigma para values for the substituent at the C3 position of the trans substituted acrylic acid and the pK of the acids comparatively a large value. So this is not too much related to your study. So you don't need to remember or memorize every value for this Hammett constituent constant or substituent constant, but remember this is only takes account for the para and the meta positions. Okay, and electron depending on the electron donating ability or electron withdrawing ability, the values vary for the Hammett constant. Okay, and we will see more in more detail this about this constant and the equations in the next questions. So now I will move toward the problem number 9. So problem number 9 it says that okay, this is the your Hammett equation, and this suffix m it actually denotes the meta and suffix p it denotes the para. So the sigma m means the Hammett constant for the meta value for the phenol substituent OH is 0.12, whereas the sigma para sigma p or at the para position this Hammett constant value is 0.37. What do this sigma p and the sigma p, m stand for? Number A, electronic effect of the phenol substituent at meta and para positions respectively. Number B, hydrophobic effect of the phenol substituent at the meta and para position respectively. Number C, steric effect of the phenol substituent at the meta para position respectively, and number D, acid effect of the phenol substituent at the meta and para position respectively. So the values are given for the Hammett constant is 0.12 for the m and sigma m, and for the sigma p for the is 0.37 for the phenolic group, and you have to identify which of the what does this two values stand for. So this is a very easy question. If you have paid attention to the last question, I think all of you should answer this question correctly. are there any correct answers? Number A. So we have two number A, right? Number B, number A, number A. Okay, let us check what is the correct answer. So the correct answer is number A, the electronic effect of the phenol substituent at the meta-para position respectively. So I have discussed in the previous question what is a Hammett constant, and this Hammett constant they refer to the electronic effect, right. So electron donating or electron withdrawing. So the substituent constant sigma, the or Hammett equation of substituent constant sigma, polar reactions are strongly affected by the substituents on the equilibrium constant and rates of the reaction of the organic molecules and ions. So 1937, Louis P. Hammett suggested that effects of the meta-para substituents on the ionization constant of the benzoic acids could be predictors of the electronic influences of the substituents in a variety of reaction. And why? Now, because number A, the large number of substituted benzoic acids are readily available. Number 2, ionization constant are easily determined. And number 3, substituents on aromatic rings are held at a fixed distances from the points of the reaction. Okay. So, this is the about the Hammett equation and the Hammett constant. So, now let us go to the problem number 10. It says that when two drugs act on the same receptor, the resulting drug interaction is said to be which of the following? Number A, predictable, number B, unpredictable, number C, additive, and number D, empty therapy. When two drugs act on a same receptor, the resulting drug interaction is said to be which of the following? Predictable, unpredictable, additive, or empty therapy. Try to answer this in the chat box. Which of the following you think is the correct? So, is there any answer for the question? Numbers B, number C, number C, number C. So, we have 3 number C and 1 number B. Okay, let us check. So, the correct answer is yes, number C, additive. So, drug synergy. When drugs are given in combination, their effects can be antagonistic, sub-additive, additive, or synergistic. So, another term for this additive is the synergistic. Drug synergism arises when the therapeutic effect of 2 or more drugs are used in combination is greater than the sum of effects of the drugs administered individually. So, let us say there is a same receptor where the 2 drugs acts, but the 2 drugs are not 100% efficient for that particular receptor. But sometimes it happens when the 2 drugs are given all together, the synergism which brings is very much effective, and this is the called the additive or synergistic effect. Okay. So, we have already looked at the part of this when we drug alliances look at it. So, let me little bit more formally. So, drug synergy is when 2 drugs are given in combination. They can be antagonistic, which means that one drug is going to cancel out the effect of other, or it can be sub-additive, which means that this is going to be little bit of addition in the efficiency, or it can be additive, means the effect of A can be added to the effect of B, and that is going to result in a combination therapy. but more importantly what we look for it is synergy. So, we here synergy will refers to when therapeutic effect of these two drugs are more used in a combination is greater than sum of the effects of the drugs administered individually. So, difference between additive and synergy is what I add these two drugs and the concentration at which the efficacy is the net effect does not go up, but in synergy some of the effects are larger than the individual drug. Okay, so in the additive what will happen, say let us say two drugs are exerting their efficacy at some 50-50 ratio. So, when you are adding up that it will make up to the 100%, okay, and in the synergism what will happen, the sum is the larger than the individual drug, and the additive the sum will be exactly same. So, the most the both of them are used in a same manner. Okay. So, one can think the synergy is inhibiting the drug destroying enzyme. So, we have already looked at this in previous exam when the synergy. So, particular molecule may not have the therapeutic effect of its own, but it only protects the drug from being destroyed. So, this is also called the sensitizing of the drug or sensitizing the pathogen to the drug, but it also if the primary drug and the inhibitors are destroying enzymes are administered together, then they are called the synergistic effect. Like in case of ampicillin and clavinoid, so they are administered together. So, you can protect ampicillin from the beta lactamase. So, the example is like say what is so there if there is a combination which is very important like ampicillin and clavinoid, and ampicillin is a I think you all know beta lactam ring containing antibiotic, and which is prone to be destroyed by the beta lactamase enzymes, and this clavinoid it can be it actually protects the ampicillin from this particular enzyme, and this is also an example for the additive effect. Okay. Now, problem number 11, it says that what sort of value of the sigma would signify an electron withdrawing substituent. Your options are number A negative value, number B positive value, number C 0, and number D it is impossible to say. Sigma is the Hammett constant which we discussed earlier, right. So, what sort of value of sigma will signify an electron withdrawing substituent? So, this is your problem number 11. Now, I will give you a break of few minutes. Okay, you try to answer the question in the chat box. I am not leaving the class, I am here. I will just keep my camera and the microphone off, but do not leave the class and try to answer the question in the chat box. After 2 to 3 minutes, I will come back and I will check the answer. Okay. Hello. So is my voice audible? So hello, is everybody is present in the class? Yeah. Okay, so we have few answers. Number B positive value, number A. Okay, let us see what is the correct answer. Okay, so correct answer is, yeah, it is number B positive value. So this is the values for the substituent, Hamid substituent constants. Now when I am discussing this Hamid substituent constant, I will let you know that you don't need to memorize the values, okay, but just remember like what the positive value signifies and what the negative value. Okay, somebody wants to join. So, but you have to remember like what the positive value implies and what the negative value implies. Okay. So, if there is a electron withdrawing substituent, it will exert the positive value, like as you can see from this table, like there is a acid oxy group CH3C double bond O or CH3CO, or there is a acetyl group like CH3CO amine. So, these electron withdrawing group like bromo, carboxy, chloro, cyano, ethoxy. Okay, ethoxy is positive, negative both actually. So, there may be some values which can be like this, like ethoxy, methoxy, this kind of groups. So, they exert both positive, negative value depending on their positions. Okay, like fluorine and hydroxy also can show the electron withdrawing or electron donating both tendency. Actually, for the hydroxy, methoxy, ethoxy, this group what will happen, like the oxygen is the electron negative element, right. So, the electron negativity of oxygen is electron negative element, that is how it will pull the electrons toward itself of a bond, particular carbon oxygen bond, right. But due to the lone pair of oxygen, there is also electron donating tendency of the this kind of group. Okay, that is why the values are positive at a place and negative at a place. Okay. Now, where the value is positive and where the value is negative, if you can look at it correctly. Okay, so this is a negative group are denoting by the electron. Let me write. So, if the value is negative, it denotes what? It denotes the electron donating group, right. Electron donating group means this amino, the values are negative, like tertiary butyl, acidoxy, okay, so not acidoxy, the methyl, these kinds of electron donating groups exert the negative value, and positive value it is exerted, positive value it is exerted by the electron, okay, once again, withdrawing group. Okay. Now, as you can see these groups like and all of this are respect to this hydrogen. Okay, the value of Hamid constant for the hydrogen is 0. Okay, it neither shows electron withdrawing or nor shows the electron donating tendency. But if there is a hydroxyl like OH or OMe or OET, means oxygen containing group. So, what will happen? It will show electron donating and electron withdrawing tendency at different places. So, as you can let us say there is a benzene ring. Okay. I will just erase it later. So, there is a benzene ring, and forgive my bad handwriting. So, if there is a particular ring, say R here, and there is a OH hydroxyl here at the meta position. So, in the meta position, the oxygen lone pair cannot be act as a electron donating. So, that is how it will only exert the electron withdrawing tendency due to the electronegativity. But if the same substituent is in the para position like this R, and there is a OH. So, if it is in the para position, so what will happen? The hydroxyl group, it will just take part in resonance and make it as a negative. So, that is why, as you can see, hydroxyl group, the para position the value is in negative, but the meta position the value is in positive. Okay, because hydroxyl group can exert positive negative values at based on their position due to the nature of this oxygen molecule, which is at a time it is electron withdrawing due to the electronegativity and electron donating due to the lone pairs. Okay. So, again I am saying you do not need to memorize the values, but remember when it is positive and when it is negative. Based on this you may need to solve some mathematical questions also. Okay. Okay, now I will move toward the next problem. So, problem number 12, it says that which of the following is an inhibitor of inosine 5' monophosphate dehydrogenase? Number A, dopamine, number B, mesoribine, number C, propanolol, and number D, ciprofloxacin. So, you have to find out which is the correct inhibitor for the inosine 5' monophosphate dehydrogenase. Is it dopamine, mesoribine, propanolol or ciprofloxacin? Everybody try to answer the question in the chat box. It does not matter if your answer is correct or wrong, but at least you should try. Okay. So, I want everybody to try and answer this question in the chat box. So, is there any answer for the question? Number A, number A, number B, number A. So, okay, so we have one number A and 3 number A and 1 number B. Okay, let us check. So, the correct answer is number B, mesoribine. Okay. So, this is the structure for the drug mesoribine, and as you can see, this contains imidazole ring here, and this is a ribose kind of moiety, and so this is the metabolic pathway. So, this is only for your knowledge, because I do not think it is important for you to memorize these things, but remember. Okay, so mesoribine is the inhibitor of the inosine 5 monophosphate dehydrogenase. Now, where this this particular enzyme is used. So, as you can see, this can be abbreviated as IMP dehydrogenase, and this is used at this particular pathway. Okay. So, mesoribin, it actually converted to the mycophenolic acid and mesoribin monophosphate by this adenosine kinase, and this adenosine monophosphate, it is converted into RGMP, and by this in enzyme IMP dehydrogenase or inositol 5 monophosphate dehydrogenase, and this mesoribin, it inhibits that particular pathway, and this particular pathway actually is important for the kinase and guanosine. This all are important in the cancerous things, okay, for the particular metabolic pathway of guanine, guanine and mesoribin, and these are all involved in a cancer, I mean the cancer expression or the carcinogenic expression for the body. So, you do not need to remember all this metabolic pathway here, it is only for your knowledge. So, remember the name of the compound, which is mesoribin, and it is inhibitor for the inosine 5 prime monophosphate dehydrogenase. Okay. Now, I will move toward the next problem. So, problem number 13, it says that what term is used to describe the process by which the best line fitted through the set of the data points on a graph. Your options are: number A, linear regression analysis by the least square method; number B, linear fitting analysis by the least square method; number C, linear fitting assessment by the least square method; and number D, linear regression assessment by the least square method. This is something a different question, but it is very important because we are learning about the QSAR and the molecular modeling and all of this. So, all of there we need to apply some mathematical techniques also to build up the models. Okay. Now, you have to identify what term is used to describe the process by which best line fitted through the set of the data points on the graph is called. It is linear regression analysis by the least square method, linear fitting analysis by the least square method, linear fitting assessment by the least square method, and linear regression assessment by the least square method. Everybody try to answer the question in the chat box. Which of the following you think is the correct answer? So, is there any answer for this question? Number A, number A, number A. So, we have 3 number A, right? Okay, let us check. So, the correct answer is yes, number A, linear regression analysis by the least square method. So, least square method, a form of mathematical regression analysis, is used to determine the line of the best fit from a set of the data, providing visual demonstration of the relationship between the data points. Now, if there are few points like here, 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 here. So, now there is not possible to draw a particular line which actually intersects all the points, right. So, let us say there are 4 points like here one point, here another point, here another point, and here it is number 4th point. So, if you draw a line like this, okay, sorry, it is very actually problematic to draw it like here, but I will try. So, if you try to join the lines, the points in a particular line, so like this, okay. So, it is impossible to draw a straight line here with using the PowerPoint pane. but if you draw a line which connects these 2 points, so this line will be very much far away from these 2 points. And similarly, if you draw, if you join this 2 line with a straight line, so the straight line will be far away from these 2 points, like. So, the linear regression method, what it does basically, it actually draw a particular line which is in particular distance from the all of the points, okay, and the error is has to be minimized by it. So, linear regression analysis or the least square method is one technique for estimating the line of the best fit. Once an equation for a line best fit has been determined, forecasts can be made. The least square method of a linear regression analysis involves using the following formula of an A and B in y equal to a plus bx. Now, B, it is the formula. So, this is the formula which is used for the least square method by linear regression analysis, y equal to a plus bx. Okay. And say there are 2 points. Now, what is y, what is x? Now, if there, as you know, in the graph there are y axis and x axis, and the values are related of the x axis parameters is called the x values, and the values which are related to the y axis parameter is the y values. Okay. And what is the B here? So, B in this equation, the B is the n summation of x y minus summation of x summation of y divided by n summation of x square minus summation of x y square x whole square, okay, and a equal to y bar minus b and x. So, what is this terms stand for? N is the number of pairs of the data. So, in your data, let us say where we have 3 pairs, like, right, let us say there are pairs like this. So, there are x and y, okay, x and y. So, let us say there are 2 and 3, there is 4 and 7, and there is let us say, okay, forget my handwriting, 5 and 8. So, let us say there are this kind of data sets, okay, and this are the 2, 4 and 5, these are the x values, 3, 7 and 8, these are the y values. So, n is the number of the pairs of the data, which will be 3, because we have 3 pair of the data here, right, and x bar is the mean of the x value of the data pairs, which is the mean of the 2, 4 and 5, and y bar is the mean of the y values in the pair of data. And what is the x and y? So, we have to actually do the sum of it. So, sum of x y means sum of this 3 into 2, some plus 4 into 7, 5 into 8, and sum of x, sum of y means there is we have to multiply sum of x means 2 plus 4 plus 5 into sum of y means 2 plus 7 plus 8, and that is how the calculation happens. Okay. So, this is very easy actually equation, and you can just try it also by yourself, taking a particular set of the 5 pairs of numbers and try to calculate by using the formula. You can easily do it, and after assessing A and B, you can just put it A and B, and you can just use in a formula of straight line, right. So, y equal to mx plus c. So, m is the slope of the line which is denoted by b, and c is the intercept in the y axis which is denoted by a, and the values are determined from this equation. Okay. So, this was about the least square method and the linear regression. So, now problem number 40, it says that which of the following statements is true. Number A, hydrophilic compounds have high value of P. Number B, hydrophobic compounds have high value of P. Number C, acidic compounds have high value of P. Number D, basic compounds have high value of P. Now, for this question, I want you to answer the correct option which you think is answer the option which you think is the correct. Also, I want you to mention what is what is denoted by this P. Write in the chat box what is denoted by this term P, and then which of the following options you think is the correct. I want all of you to try to answer it. What is the term which is denoted by P, and then correct answer which you think. So, are there any answers? Number B, number B. Okay, so I have also asked, right, what is this denoted by P, the capital P. What is denoted by capital P? I think you should know it, because we have been discussing it in quite few time. So, does anybody know what is denoted by capital P in the which is mentioned in that problem? Okay, let me just show you the answers then. So, capital P is nothing but the partition coefficient, right? So, yeah, the correct answer is hydrophobic compounds have high value of P. So, what is P? P is the partition coefficient, and I think we have discussed it earlier also, right? So, P is the partition coefficient or distribution coefficient, which is also described by D, is defined as the ratio of concentration of a compound in a mixture of two immiscible phases at equilibrium, a biphase of liquid phases specifically for unionized solute, and the logarithm of the ratio is thus log P. Hence, partition coefficient measures how hydrophilic or hydrophobic of a chemical substance is. Okay, so this is called the separating funnel. Okay, and based on the solvent's density, this kind of bilayer is formed in the form of aqueous and organic layer. If the organic layer is heavier or denser like DCM, it will be in the lower part and water will be upper part, and if the water is denser than the organic layer like ethyl acetate will be in the upper layer and water will be in the lower layer. Okay, and this is called the this apparatus is called the separating funnel. So, partition coefficient P or distribution coefficient D is the ratio for the concentration of a compound in a mixture of two immiscible phases at the equilibrium. The most common physicochemical descriptor is the molecule's partition coefficient in octanol water system. After administration of the drug will go through the series of partitioning step. Number A, leaving the aqueous extracellular fluid. Number B, passing through lipid membranes. Number C, entering the other aqueous environment before reaching the receptor. In this sense, a drug is undergoing the same partitioning phenomenon that happens to any chemical in a separatory funnel containing water and nonpolar solvent like hexane, chloroform, ether, or there are DCM ethanol acetate also. Okay. So, this the answer was correct. Hydrophobic compound have a high value of partition coefficient because the concentration of compound will be higher in the organic layer. So, now I will go toward the next problem. Problem number 15, it says that the antibacterial activity of a number of penicillins was found to fit the following QSAR equation. Which of the statements is true? So, this is the particular compound, okay, and the equation is this: log 1 by C equal to minus 0.445 pi plus 5.675 and in bracket n equal to 20, r equal to 0.909. So, the value of the regression coefficient is not acceptable. Option number B is activity increases with the hydrophobic substituent on the aromatic ring. Option C, activity decreases with the hydrophobic substituent on the aromatic ring. Number D, activity decreases with the electron withdrawing substituent on the aromatic ring. So, identify which of the following is the correct answer. Again, I am repeating, the antibacterial activity of a number of penicillins was found to fit the following QSAR equation, which is mentioned here. And which of the following statement is true? The value of regression coefficient is not acceptable. Number B, activity increases with the hydrophobic substituent on the aromatic ring. Number C, activity decreases with the hydrophobic substituent on the aromatic ring. Option D, activity decreases with the electron withdrawing substituent on the aromatic ring. So, are there any answers for the question? Number B, yeah, partition coefficient, it was correct. So, we have two number B's, right? Okay. So, the correct answer is number C, activity decreases with the hydrophobic substituent on the aromatic ring. So, log P and QSAR, very few drugs where the activity depends on the log P. General anesthetics or ethers fits into the following equation. So, this is an example, and this equation is actually parabolic in nature and possible to predict the anesthetic activity of the log P values. Okay. So, when we look at the log P and QSAR, there are very few drugs whose activity depends only on the log P, although the log P is an important parameter, and for example, general anesthetics feed the well into the following equation. So, we have typically ethers which fit into the equation. So, this is an example which is given here, okay, and then now it is a common example which is given here for the anesthetics. So, we have typically ethers which fit well into the equation. Log this equation, log 1 of the log 1 by C equal to Z minus 0.22 log P square and plus 1.04 log P plus 2.16. So, if I plot this, I will get a parabola like we have seen previously. Now, what happens is that because I am able to write an equation that describes the activity, now because I have can find out when I get the maximum activity. So, it helps us to predict the anesthetic activity given by the log P value. So, this is the only example, and so as you can see, this again give the estimation how the equation goes for, and the activity it will decrease with the hydrophobic substituent on the aromatic ring. Okay. So, problem number 16, it says that drug resistance of trimethoprim is generated due to number A, efflux pump, number B, sequential blocking, number C, mutation in target, and number D, insufficient drug concentration. We have been discussing the drug resistance by various agents, and the examples like we have discussed for the sulfur drugs and also efflux pumps and beta lactams also. Now, this question is related to the drug resistance of the trimethoprim, and you have to identify why this is generated. Is it due to the efflux pump, number B, sequential blocking, number C, mutation in the target, and number D, insufficient drug concentration. So, are there any answers for the question? Number B, number B. So, we have two number B. Okay, let me check what is the correct answer. So, the correct answer is number C, mutation in target. Okay, so let us say you have a protein, so the mutation can occur here, and this results in the conformational change which changes the binding pocket of the enzyme. So, this is now not very good binding good for the binding anymore. For example, the resistance to the antibiotic trimethoprim derives from the single mutation of a single amino acid in the target enzyme, which is dehydrofolate reductase. So, the properties of the singly mutated in the enzymes differ somewhat from those normal enzyme, but it is still binds to the substrate dihydrofolate. So, this is the biosynthetic pathway. Okay. So, let us say this is the pteridine and this is the PABA, which is para-aminobenzoic acid, and this is converted to the dihydropteric acid, which is by dihydrofolate synthesis, and sulfonamides either is the inhibitor for this pathway. Again, dihydropteric acid, it is converted to dihydrofolic acid by the dihydrofolate synthesis, and this is inhibited by the glutamates. Okay, or this is also not inhibited, this is catalyzed by the glutamates, and dihydrofolic acid is converted to tetrahydrofolic acid, which is important for the bacterial growth, and this is catalyzed by the dihydrofolate reductase. Okay, and this particular pathway is inhibited by the trimethoprim enzyme, trimethoprim antibiotic, and this target enzyme is dihydrofolate reductase, where this inhibitor trimethoprim binds and it inhibits the particular pathway, so that the dihydrofolic acid cannot bind. But what happened, due to the single point mutation in a single amino acid, what will happen, this trimethoprim, it will not bind anymore to the particular the enzyme, the dihydrofolate enzyme, but the single point mutation is not important enough for the substrate dihydrofolic acid. Okay, so what will happen, the drug resistance of trimethoprim is generated, because your substrate can bind to the particular enzyme after the mutation also, but your drug cannot bind there. Okay, and this is the reason the trimethoprim get the drug resistance. Okay, the single point mutation. So, correct answer will be mutation in the target. Okay. So, now next question, problem number 17, it says that aminoglycosides are resistant due to number A, target mimicry, number B, target overproduction, number C, efflux pump, Number D, lack of the electrical potential gradient across the bacterial membrane. So, you have to identify the correct answer. Aminoglycoside resistance is due to number A, target mimicry, number B, target overproduction, number C, efflux pump, number D, lack of the electrical potential gradient across the bacterial membrane. Write in the chat box which of the following you think is the correct answer. Okay, so are there any answer for this question? Number B, number D, number C. So, we have 3 different options, right? Okay, let me check. So, the correct answer is number D, lack of an electrical potential gradient across the bacterial membrane. So, aminoglycoside is a medicinal and bacteriologic. Okay, so one second, I will just on the laser pointer. So, aminoglycoside is a medicinal and bacteriologic category of traditional gram-negative antibacterial therapeutic agents that inhibit protein synthesis and contain as a portion of a molecule an amino and modified glycosides or sugar. Aminoglycoside antibiotics display bactericidal activity against gram-negative aerobics and some anaerobic bacilli where resistance has not yet arisen, but generally not against gram-positive and anaerobic gram-negative bacteria. So, aminoglycoside antibiotic resistance can arise from the lack of the quinones that mediate the drug transport or from lack of an electrical potential gradient required to drive the drug across the bacterial membrane. So, there is one way which can occur by changing the net charge on the membrane. So, you can example there is a phosphatidylglycerol membrane, it can be charged to lysyl phosphatidylglycerol groups, then it converts anionic group to cationic group. So, this change can affect the permeability of the drug. So, if the permeability of the drug goes down, then clearly the efficacy will go down. In this way, the drug with the same charge can actually now be repelled. So, aminoglycoside antibiotic for example became inactive because the quinones that mediate the drug transport or the quinones that mediate the drug transport or from the lack of an electrical potential gradient required to drive the drug across the bacterial membrane. So, the two can result the decrease of the aminoglycoside which is going to result in resistance. So, basically what will happen if your drug is, let us say it is the positively charged, okay, and your membrane is negatively charged. So, it will easily go up to the membrane because of the positive negative attraction, but if there is some mutation or some change in the potential gradient or some due to some changes, the membrane is became again the positively charged. So, what will happen, the positive will repel, now the drug cannot go inside the cell. So, this is the basically the example where the aminoglycoside resistance happen. Okay. Now, problem number 18, it says which of the following is not a mechanism of resistance by the quinolones. Number A, lack of potential gradient, number B is single point mutation, Number C, active efflux system. Number D, mutation in the genes of the DNA guidance. So, which is not a mechanism of resistance for the quinolones? Try to answer it in the chat box. So, is there any answer for that question? Number D, number D. So, we have two number D, okay. Let me check. So, the correct answer is actually number A, lack of potential gradient. So, it is not the mechanism of resistance by quinolone. So, resistance can emerge during a therapy, especially with as bacteria as aureus or as organosa. A single mutation is sufficient to cause resistance. Resistance is chromosomal rather than plasmid mediated. Mutations occur in the genes of DNA guidase or topoisomerase, appear to primary site of the sphumony active efflux pump, present in both positive and negative bacteria. So, these things are they actually take part for the bacterial resistance for the quinolone. Resistance in chromosomal rather than plasmid mediated. The mutations occur in the genes of DNA guidase which is topoisomerase type 2 or active efflux pump, okay. But the lack of potential gradient is not the mechanism of resistance of the quinolones. Problem number 19, it says that the QSAR equation relating the general anesthetic activity is several ethers into their log P values is determined by the following equation and the graph, which I mentioned in the last question, I think. The log C equal 1 by C equal to minus 0.22 log P square plus 1.04 log P plus 2.16. Which of the following statements is true? Number A, general anesthetic activity increases with the hydrophobicity. General anesthetic activity decreases with the hydrophobicity. General anesthetic activity increases with the hydrophobicity to the maximum value, then decreases. Number D, general anesthetic activity decreases with the hydrophobicity to the maximum value, then decreases. So, identify which of the following you think may be correct answer. So, are there any answer for the question? Number C, number B. So, we have two answers, right? Let me check. So, the correct answer is number C, general anesthetic activity increases with the hydrophobicity to the maximum value, then decreases. So, as I have mentioned it earlier also, right, So now look at the log P and QSAR. There are few drugs which activity depends only on the log P, although log P is an important parameter, for example for general anesthetics. Okay. So you have typically the ethers, so I have mentioned this part also in the previous okay. So I will just repeat it once more. So the equation is log 1 by 1 log 1 by C. So this is a parabolic in nature. Okay. So now it helps us to predict the value. So in my x axis, if I have very low log P value, then it quietly like to activity will be low, whereas consecutively if the very high log P value, then it is likely that it will be low activity. It is quite likely that I will get a low activity, and therefore new set of compounds to be synthesized. So as you can say, this is a parabolic in nature, and this is the log P value in the x axis and log 1 by C value in the y axis. So for the optimum activity, the log P value should not be too high or too low. Okay. So it should be somewhat in middle where the activity will be highest. Okay. Now last question, it says that the given the following log P values, what is the log P value for the disubstituted structure? So as the options are number A 1.97, number B 2.01, number C 2.25, number D 2.29. So this is the log P value for this benzene ring, which is 2.13. Log P value for the O-methoxy is 2.11. Log P value for fluorine containing 2.27, and for the OMe and fluorine it is how much? You have to, using these values, you have to calculate the log P value for this particular compound. So take 2 minutes and then let me know what is the correct answer after the calculation. So have you calculated the value? Number B. So we have only one answer till now. Okay, I will show you how to calculate it. So the correct answer is actually number C. So I will show you the calculation. So log P equal to, so the formula for calculating such molecules will be log P for benzene plus pi of F plus pi of OMe. So now how we will know what is the pi of F and pi of OMe? So we have the log P for the benzene ring, right? So this molecule containing fluorine. So the log P is 2.27. So we have to just minus the value of log P of benzene, which is 2.13. So this is the value of pi of the fluorine, and for the pi of the OMe, similarly from 2.11 we have to minus it. So it is minus 0.02. Now log P of this ring will be log P of benzene, which is 2.13 plus the this value, okay, the pi of fluorine and the pi of OMe. So it will be 2.25. So if you are given any other substituent, I think you are able to now calculate this question. Okay. So this was the last question. So yeah, today it was your week 11 session. Okay, and today we discussed the course content related to your week 12 course content, right? So now this lecture video and this PPT I will share with you for the NPTEL website. and today it is the week 10 session, and now we have completed all your 12 weeks, right. So, we have completed each and every week in our previous 11 sessions, in total 11 sessions. So, for the next class, so we will have 2 more classes. Okay. So, one class will be on the next Saturday, which is on 22nd April from this time 6 p.m. to 8 p.m. and the last class will be on the Sunday 23rd April, okay, and it will be from 10 a.m. to 11 a.m. and it will be only 1 hour class from 10 a.m. to 11 a.m. and in this last 2 class, what I will do, I will not put many questions there, okay. I will only put 5 to 6 questions in the last 2 classes, but I will more incorporate some details about the courses, okay, like we will just recapitulate what we have learned so far in this medicinal chemistry course, and I will also give you some few more points which I think should be included in the course, and I think this summary classes will be helpful to you for your exam purpose also. So, now today I will just stop the session, and just like every day I will share my email ID, so that if you have any doubt or any query, you can just drop a email, and I will see you in the next class. So, thank you all for joining, and we will meet on the next week at this time, same time, okay. So, thank you all. I will close the session for today. Thank you all for joining.